Hello, I'm Simon, and I'm here once again to discuss the development of my fighting game, Project Rocket. In the last update, I briefly covered the importance of training mode, not only as a feature for the player's benefit, but as a critical building block for upcoming core features, such as replay mode and rollback netcode. Now that I've had a chance to implement some of training mode's core functionality, I want to go more in depth, discussing the purpose and utility of each feature. If you've attempted to learn how fighting games work at a competitive level, you'd have certainly encountered the term frame data. Frame data is a determining factor in the viability of a character's moveset, as a move with better frame data generally presents the player with more options than would be available to their opponent. Since frame data is crucial to a move's utility, balancing each character's strengths without considering frame data seems foolish. Therefore, for my convenience, I implemented an in-game overlay that would indicate the frame advantage of any move. My implementation is straightforward. I check if both fighters are committed to an action, and then calculate the frame advantage based on the move's remaining duration. I use the term committed loosely, as certain moves such as hurt and block actions aren't really committed to, but it was distinct enough as a term from the concept of a stun action, which functions very differently in my game. Also, instead of programmatically determining which actions are committal, I'm merely tagging each action as committal manually. While it's certainly possible to implement a programmatic approach in my current codebase, and the current manual method does open up the possibility of simply forgetting a move, I wanted to keep it simple since I already have a list of improvements I'd like to make to my action canceling system, which a future redesign would better serve. So far, this naive implementation has been helpful and correct. One immediate takeaway is that my hurt animations are too short, and the attacker is always at a frame disadvantage, even after successfully hitting the opponent. I expected this would be an issue, as I made the hurt animation short, with the intention of eventually incorporating some form of hit stop that would lengthen the overall duration of the action, but I still haven't gotten around to it yet. While the current frame overlay is generally comprehensive enough, one situation where it feels slightly underbaked is when the defender enters a hurt animation that, once complete, transitions into another follow-up hurt animation. Once the final hurt animation starts, the frame data overlay will be corrected. Still, momentarily, the frame data will calculate the frame advantage as if the initial hurt action is the only action that needs to be completed. This issue is most prominent when one fighter sweeps the other off their feet. When a fighter is swept, they immediately go into an action titled Hurt Swept, then transition into a generic knockdown to floored animation, depicting the fighter slamming on the ground, then slowly rising to a semi-seated position. Despite briefly misleading the player into thinking an attack is negative, I don't believe this momentary confusion is severe enough to prioritize over implementing other features and fixes. Implementing save states was pretty straightforward. All the current implementation does is save an extra copy of the game state in memory. Saving and loading are then accomplished by copying the mutable state between the active game state object and the copy. While there's not much to it, it's very effective. Now, it's far easier to check if complex state machines, such as the projectile logic, will break if I roll back from a previous state. I also took the time to add some extra UX improvements. These improvements include adding toggles to the pause menu to enable and disable the input history and frame advantage overlays, clearing the input history when loading a save state, freezing animations when the game is supposed to be paused, and much more. After finishing my work on training mode, I was a bit disheartened. What was supposed to take a week turned into 2 weeks of work. Although there was some time lost due to me realizing I should probably save my action data in a spreadsheet in case something broke, which took 3 days and it was rough. However, to my surprise, when I started tinkering with replays, I managed to program the core functionality in a single day. I'm still unsure what made this so much easier to prototype in the training mode. I definitely felt more motivated to work on replays than training mode tools, frame data notwithstanding. I suppose it's also partly due to the replay system reaping the rewards of my commitment to deterministic gameplay logic. All the replay system has to do is record player input in a text file. To play the input back, simply parse the contents and then mock some controller inputs. All I can say is I'm relieved not to be working through another 2-week slog. Now, I'm finally about to tackle my most anticipated aspect of the project, rollback netcode. Thank you for following the development of Project Rocket. See you soon.